Hello, friends. How we doing? Sorry I'm out again today. Meetings at schools, etc. So these are the answers that I'm sure you already checked on the answer key from yesterday, but just to be safe, hit the pause button, double check your work, and we'll go from there. All right, now that you've unhit pause or hit pause again, so it's not pause because if you hit the pause button again, then whatever. Here we go. We're going to talk about this is the last day about talking about rational exponents. And we're going to start solving things, etc. on Monday. So we are going to do similar things we did yesterday, except we're going to do it with different roots. So in this case, we've got the cube root of 40. And as our little friend there with the geeky glasses, I'm sorry, that's disrespectful. Anyway, the guy, actually, yeah, that's a picture of me in high school. So he's wondering, do we need to look for groups of 3? And the answer is yes. Yesterday we looked for groups of 2 because that was our index. Today we're going to look for groups of 3 because that's our index. And so when you break this down, you're going to break down the 40. The 40 breaks down into the 8 and 5, or you might have gone 2 and 10. And then, so I actually have 2 to the 3rd power times 5. And so the cube root of 2 cubed, those are inverses of each other. Oops, not an equal sign. The cube root of 2 cubed is just going to become 2. And the cube root of 5 stays there all by his lonesome. So same process as yesterday. Exactly the same, with the exception of you need 3 of something to get it out. Yesterday, when we were doing square roots, we needed 2. Now we need 3. And the best way to do this is just to plug through and try some. Now, this is one of those times where variables are actually easier to deal with than coefficients. Because here, I mean, you can break this down fairly easy. You're going to say, hey, I've got cube roots. And I'm going to break that x down into x cubed times x. Now remember, technically that's to the first. And then I've got y cubed, so that's 3. I got another y cubed, that's a total of 6. Another y cubed, that's 9. And there's y to the first, so that's 10y, just like we have up there. And then everybody who has a 3 gets to go out front. So they are all going to go out front. So I'm going to get x times y times y times y. Because again, remember, if it's cubed around the inside, it's going to be just a single one on the out. Cube root of x y on the inside. And yes, as always, I understand that some of you might be able to shortcut this a little bit. Again, remember, I'm also teaching this to make sure that if you are having an issue with it, that you can look at it and say, hey, how's he doing that? And again, remember, cube root of something cubed is just going to be that something. So the cube root is asking what number cubed is equal to the number on the inside. So break it down into groups of 3. It's kind of like actually in class, okay? You know, where you've got, all right, we're going to have, teacher says, break down into groups of 3. So, you know, there's 3, and there's 3, and those 3, and those 3. Except in this case, you have to be like, you know, boys and girls are being separated. So, so I've got one big group of, so then here I've got one group of boys, and I've got 3 groups of girls, and then 1 boy left over and 1 girl left over. Another example. Ooh, what is the index of 4 going to imply? So again, groups of 4 are needed. So 16, let's mess with that. 16, 4 and 4, 2 and 8, doesn't matter. That's going to bust out into 2 times 2 times 2 times 2. Again, remember, I'm going to pause here for a second. we had talked about saying, okay, you know, there is something to be said for every time we do this, writing out powers. So if I have one, or one times, yeah, that's dumb. 1 to any power is 1. So if I have 2, 2 squared is 4, times 2 is 8, times 2 is 16, times 2 is 32. 3 squared is 9, times 3 is 27, times 3 is 81. And again, you writing this down every single time and thinking through it is going to help cement it in your brain. Versus, oh, let's just copy it down blindly. I don't want to think. Don't do that. Okay? You're not robots yet. Once the matrix happens, then yes. But, you know. Anyway, so once you do that, so, you know, when you see 16, the hope is you're going to be like, hey, wait a second, that's right there. And it's right here. I want something to the 4th power, so I'm going to take the 2. Okay, so anyway. So I now have 4th roots, and again, I'm going to write everything in terms of groups of 4, so this is going to become 2 to the 4th. I've got x to the 4th, so that's 4 of them, and then I've got another 4, so that's x to the 8th, and then y to the 4th. That already comes pre-packaged. I mean, you can't fault that too much. So then remember, sorry. See, it's just like class. So each one of these then breaks down, because if I have a group, remember, on the inside of the root, it's talking about, you're like dealing with individuals. On the outside of the root, you're dealing like with how many groups you have. So in this case, in this case here, I have one group of 2. This is a group of 4, so I'm just going to say if I have 4 people together, I've got one group of 4, I've got another group of 4, I've got another group of 4. So then, you're going to write that down, and then you're going to make it look all nice and pretty, because after all, that's what we do as humans. We want to look good. And then you stick the answer in a box. Do you think this works with other roots? You know it does. Oops. There we go. 5th roots. That's amazing. What you may want to do here, and I think I said this yesterday, but before I do anything else, I'm going to actually break this down a little bit, because once you start dealing with higher roots, your numbers, particularly with your coefficients, are going to get big. And when the coefficients get big and you don't have them broken down into powers, things get a little goofy. So the 8 becomes 2 cubed. The x stays. The y to the 7th stays. The 6 is going to become 2 times 3. And then I have x to the 6th. Okay, so now if I group everything by term, I'm going to have 2 to the 4th, x to the 7th. Oops, I forgot the 3. Yeah, yes, I know you were saying it. I'm sorry. I couldn't hear you in the future. Okay. So you've got that. Now notice the numbers aren't doing anything. Okay? Because, I mean, we don't have a group of 5. Sometimes you're just not part of the group. And in this case, the 2s and the 3s are not big enough to make a group to go out. They don't have a group of their own. So, man, where's the rewind button? There we go. All right. So, these are going to stay in here. So I'm going to have 2 to the 4th times 3. These up here, and I know some of you guys are yelling in the future again, but again, we don't have the ability, well, at least that you know of, to do this. All right, so maybe I'll rewrite what I just wrote up over here. So I've got 2 to the 4th times 3 times x to the 7th, y to the 7th. Okay, so then this is going to break down to x to the 5th because I have a group of 5. Oh, 2 lonely x's. Ooh, yeah, I have a group of y's. And I have a group of 2 that's going to stay on the inside. So when you do that, then these ones are going to get out. So I'm going to have a group of X and a group of Y. We know that those groups are big as 5. And then over here, we get the lonely 2 X's together who are going to hang out together, and the same thing with the Y's. And then once again, remember, make it look good. So we're going to multiply all that out. So 2 to the 4th times 3 is 48. X squared, Y squared. All right. Do you have one more example? I might have one more example. Ha ha ha. You thought you were going to get shortchanged today. The answer is, of course not. Now, if you have things here, and we did this a little bit yesterday, but again, remember, if you've got radical exponents or if you've got rational exponents like this, you can change these into radicals. Now, before you do that, it's going to be important to get the common denominator. You have technology to do this. Don't just like, I don't know how to. You guys have your phone calculators. You have the ABC button. You've got the math frac button. Make it work. So 2 to the 5th plus 1/9. Common denominator is going to be 45. So I'm going to multiply this by 9 over 9 because that's multiplying by 1. 5 over 5. So common denominator 45, and I'm going to get 23 over 45. So that means that this, because of that, this is technically now x to the 18/45 times x to the 5/45. So my answer is going to be x to the 23/45. Mr. Hayes, we're never going to do this. No, but you may not, but you're going to be lucky that somebody did, because that's why you can drive your car. That's the reason why you have your iPad, iPod, iPhones, iWatches, all that other good stuff. All right, and then, all right, closer, hit pause button, do this. Hey, welcome back. All right, so again, first things first, let's bust this all out into a single cube root. Actually, I'll do that up over here. Okay, so the single cube root, I've got, if you want to bust this out, so I've got 2 squared times 2 times 3. So that's from the 6's. Then I have x squared. It's an announcement.
Good morning, all Wildcats. Wildcat 8 readers are now...
And we're back. So once you have that, now you can start to see how this is going to fall apart. Because when I simplify this, I'm going to get 2 cubed. And then times 3. So that's going to be all by itself. Then I'm going to have x to the 6th and y to the 6th. Now, hopefully what you're going to start to see is you're going to say, well, wait a second. 6 divided by 3, that's going to be 2. And then you'll just jump to the answer. If you would like to write this down into groups of 3, please do. So I'm going to do that down here. So the 2 is going to come out. I'm going to get a group of x's, another group of x's, a group of y, and a group of y. I know you guys are saying group of x's. Mr. Hayes, you said you never dated anybody. You're right. I don't have a large group of x's. But, so the 2 is going to come out front. I'm going to get 2 x's, or 2 groups of x's, actually. And then on the inside, I'm just going to have cube root of 3. So then the simplified version, the one that looks all pretty, the one that's getting ready to go to prom, is going to look like this. Ta-da. And hopefully that's what you have. So balance your time. You've got a worksheet to work through. Answer keys will be provided. And I believe that's about it. So thank you, everybody, for being so attentive. Your attention is commendable. And I will see you next class period. Have a good one.